Hi, welcome once again to another lesson. In this lesson, we will see how to sum an arithmetic progression. We'll get started with understanding how to arrive at this equation, how to prove this equation for the sum of an arithmetic progression, and then we'll also use this question to understand how to apply this equation in solving problems. That said, let's get started. Now, by now you'll be familiar with this equation for this nth term of an arithmetic progression that says Tn is equals to a plus n minus 1 into d. Now, so that if Tn is equals to a plus n minus 1, and we know that our a is our first term and the d is a common difference, so that if T1, which is the first term, is equals to a, my T2, which is the second term, will be equals to a plus d. So also my T3, which is the third term, will be the same thing as a plus d, the second term, plus d, that is a plus 2d. My T4 will be equals to a plus 3d. And it continues that way to my Tn, which will be equals to a plus n minus 1 into d. Now, so if I have an arithmetic series such as this, as in I have Tn, I have n of my arithmetic series is T1, T2, T3. It continues this way up to Tn, The sum of this series, Sn of this series, will be the same thing as T1 plus T2 plus T3 plus up to, we add it up to Tn. So that if I add it this way, I can conveniently replace my T1. Let's replace my Sn now to be equals to, my T1 is a plus my T2, remember it is a plus d. My T3, it is a plus 2d. I'll continue this way until I come to my Tn, which is the same thing as a plus n minus 1 into d. Now, if I sum it forward, I can also sum it from the last term. Now, I started summing this from the first term. Now, I can sum it also from the last term. Let's sum from the last term. So that Sn again is the same thing as Tn, which is my last term, plus my second to the last term will be Tn minus d. The third to the last term will be plus Tn minus 2d. Now, this can continue this way until now, rather than going to the last term, I'll be going to the first term until the first term a. Remember that the term here, which I've broken down the formula, is the same thing as what? As Tn. Now, we now need to sum up. Let's call this our equation 1. I'll call this my equation 1, and I'll call this my equation 2. Now, let's add equation 1 plus equation 2, so that if I'm adding equation 1 plus 2, Sn plus Sn will become 2Sn is equals to a now plus Tn. I'll have Tn plus a. Now, if I'm adding the second one, a plus d plus Tn minus d, it becomes plus, this becomes plus Tn, look at it this way, minus d plus a plus d. Now, minus d gives way, plus d gives way. Now, if you look at it carefully, when I'm adding the third term, this and this, the same thing repeats itself. I'll still have my Tn plus a. Now, it has repeated itself that way. You continue with that until even the last term. When I'm going to add, this will continue in the series plus until I come to the last term here. If I come to the last term here, it will repeat itself, and I'll have, this is a minus d, this is a into n minus 1 d plus A. If I'm adding this together, that is, this is actually Tn. The whole of this also is Tn. That's Tn plus A. So that my 2Sn now will become Tn plus A minus D and plus D as given way. That's plus Tn plus A plus N plus A again. That's Tn again plus A plus continues like this until I get to the nth term, which is also Tn plus A. Now, if you look at it, this is the first, the second, the third, up till the nth. So I can summarize this to become 2Sn to be equals to n into Tn plus A. If this is equals to 2Sn to be equals to n into Tn plus A, my Sn will be equals to n over 2. I'm dividing both sides by 2 into Tn plus A. Let's remember that our Tn is given as A plus n minus 1 into D. So that Sn now will be equals to n over 2 into A plus n minus 1 into D plus A. So that Sn now will be equals to n over 2 into 2A plus n minus 1 into D. That is, Sn is equals to n over 2 into 2A plus n minus 1 into D. So here we have our sum of the nth term of an arithmetic progression. Let's take our example quickly. The example says the nth term and the second term of an AP are 29 and 55. That is, Tn of an AP is equals to T9 of an AP is equals to 29, and at the same time, the 22nd term, T22 is equals to 55. Remember that Tn of an AP is given as A plus n minus 1 into D. So that if Tn is equals to 29, that is A plus 8, n minus 1, n is 9 minus 1, that's D, 8D is equals to 29. And at the same time, A plus 22 minus 1, that's 21D is equals to 55. Let's call this equation 1, and let's call this equation 2. Let's use our simple elimination method, and we'll subtract equation 2 from equation 1. This becomes minus, and this also becomes minus. This also becomes minus. So that A minus A, that gives way. 8 minus 21, that's 13. 13D is equals to 55 minus 29, that's minus 13D, sorry, is equals to minus 55 plus 29, that's minus, that's 55, here's 29, here will be 6, and here will be 26. That's 26. So that D now will be equals to minus 26 over minus 13. Minus divides minus, 13 here is 1, 13 in 26, that's 2. So D is equals to 2. If D is equals to 2, and we already have that, if D is equals to 2, and A plus 8D is equals to 29, then A plus 8 into 2 is equals to 29. That's A plus 16 is equals to 29. So that A now will be equals to 29 minus 16, which is equals to 13. So if A is equals to 13, and we have that D is equals to 2, let's remember that our Sn is equals to n over 2 into 2A plus n minus 1 into D. So that Sn now will be equals to n over 2, That's 70. And we're looking for the 70th term. S70 will be equal to 70 over 2 into 2a. That's 2 into 13 plus n minus 1. That's 70 minus 1. That's 69 times our d is 2 times 2. So that S70, the sum of the first 70 term, will be given as 35. 70 divided by 2, that's 35. 2 times 13, that's 26, plus 2 times 20, 2 times 69. Let's put that together. 69 times 2, that's 18. 138. 138. S70 will be equals to 26. That's 4 plus 138. Here's 4. Permit me to do it this way quickly. That's 6. Here's 1. That's equals to 35 times 164. 35 times 164. That's equals to 5,740 from my calculator. Thank you for staying with us. I believe that with this, you understand how to derive the formula for the sum of the nth term of an arithmetic progression, and you can work with it. In subsequent class, we'll do more examples. Thank you, and God bless you.